Hi, this is Miss Hearn. Let's get started. In this video, we're going to look at different aspects of multiplication and division, trying to understand what they really mean and what we mean by remainders, factors, and divisors, as well as greatest common factor. So here we go. First of all, let's talk about multiplication. So you can think of multiplication as adding a bunch of times. So I have here a definition: multiplication of two numbers a times b means addition of b with itself a times. So for example, if instead of having an a and a b, we have 5 and 6. 5 times 6 could be thought of either as adding up 6 5 times, or as adding up 5 6 times. Either way, you're going to get the same result, which is 30. The result of the multiplication is called a product. For example, in this case, 30 is the product of 5 and 6. The numbers that are being multiplied are factors. You may have heard the term factor before, and you might be thinking of something much more complicated, but in reality, what factor means is just something that's being multiplied. Now, there are other factors of 30 as well. For example, you can multiply 3 times 10 to get 30. So it's not unique to be factors of a number necessarily. All right, so for my students, this is the time when you would pause the video and work out the solution to your turn number 1. Use the QR code to access it. Now we're going to move on to representing products with models. So multiplication is also finding a product, and finding these products, like 2 times 10, can be represented in different ways. So the first model that we have right here shows 5 groups of 2 stars. Each circle is one of the groupings. Oops, sorry, this is supposed to be 4 times 2, which is 8. So we have 4 groups of 2 stars. And by the way, we can write this as 2 times 4 equals 8 with a little cross symbol, or we can use the dot. 2 times 4 equals 8. So here we have 4 groups of 2 stars representing the product 2 times 4. Previously in my class, we also worked on the areas of rectangles, and this is another opportunity to represent a product, because to find the area of a rectangle, you multiply its dimensions. And you see, if we take 6 tiles, let's say they're square centimeter tiles, we add up 5 groups of them, squishing them together, we get a 5 by 6 rectangle. And that has an area of 30 square centimeters. So the dimensions of the rectangle represent the factors, and the area that results is the product of the 2 factors. So that's another model that we can use to represent multiplication. So there's a fun app that you can use to play with color tiles. And for my students, we have a link that you can click on in the document in D2L, and you can pull up this app. You might have to hold down the control button when you click it. And when you do, you can pull out any number of tiles that you want of the various colors. And then you can form rectangles with them to represent a product. So for example, here I have 6 tiles that I pulled out. Each of them, think of them as a 1 square unit. I can make a 2 by 3 rectangle showing that 2 times 3 is equal to 6. Okay, so here I have already pulled out 16 tiles when I was preparing the lesson, and you can see I can do a 1 by 16 rectangle. By the way, 1 is a factor of every number, and I can do a 2x8 rectangle, what would be the dimensions of another rectangle I could form with the 16 tiles? So if you said 4x4, that's what I was thinking as well. In fact, that's the only other option, is a 4x4 rectangle. Okay, so we have 3 different ways to represent this product. By the way, if I were to list all the factors of 16, I would have to include the 1, the 2, the 4, and the 8. These are all number, oh, and 16. Well, the number itself is always a factor as well. So 1, 2, 4, 8, and 16 are all factors of 16. All right, so for my students, now is your opportunity to work your turn number 2. It says, what are the dimensions of each rectangle of area 12, which can be drawn using the color tile app? So you're going to do the same thing that I just did, except you're working with 12 tiles instead of 16, and then you'll answer a question about it. This QR code on the right is to open the color tile app. To put your answer in, you're going to use the QR code in our D2L classroom. Now let's move on to talking about division. So division is kind of the reverse of multiplication. Just as multiplication can be thought of as repeatedly adding something, you can kind of think of division as repeatedly subtracting, or at least counting how many subtractions it takes to get to 0. So what I mean by that is, if you're considering 30 divided by 6, you can think of that as asking the question, how many times do you have to subtract 6 in order to get to 0? And you'd have to subtract 6 5 times. And of course, that's because 5 times 6 is 30. You can also reverse that and say, what number would you have to subtract 6 times to get to 0? And of course, you'd have to subtract 5 6 times to get to 0. So either way you think about it, thinking about the result as being the number of times that you have to subtract 6, or the number that you have to subtract 6 times, you're going to get 30 divided by 6 is equal to 5. So that's one way to represent and think about division, but we're also going to look at some visual ways. In this example, by the way, 6 is called the divisor of 30 because it's dividing into 30, and it does so evenly. Since it goes in evenly, we say 30 is divisible by 6. You can also use the rectangular model to demonstrate this by breaking up the rectangle, which has an area of 30. The 5 by 6 rectangle can be broken up evenly into 5 pieces. Each of these pieces has a length of 6. Of course, we could also do this horizontally, break it up into 6 pieces, each of which has a length of 5. So when you're breaking the total apart like this, we're dividing it into pieces. Notice how you may have heard of fact families. 5 times 6 equals 30. 30 divided by 5 is equal to 6, and 30 divided by 6 equals 5 are sometimes referred to as a fact family. They're really describing the same relationship, just written with different notations. All right. Now, we can also do division when something doesn't go in evenly. And to demonstrate this, I'm going to use the color tiles again. So what I have here is 16 color tiles, and I'm asking the question, what's the largest rectangle that I can create using those 16 tiles, or up to 16 tiles, because I'm actually not going to be able to use all of them, where the rectangle has one side of length 5. So here are 16 tiles, and I'm going to create one column of length 5, so I can see how many of these columns I can create to make a rectangle. So I definitely have more than 5 left, so I can make a second column of length 5. And there's still more than 5 left, so I can make a third column of length 5. But looks like we don't have 5 left. So the most that I can use out of the 16 tiles is 15 of them. And what we get is a 3 unit by 5 unit rectangle. 5 times 3 gives us the 15, plus the one more gives us a total of 16. So what we're seeing here is that 16 divided by 5 gives us 3. Oops. Yes, that's right. But not exactly 3. We have a leftover or remainder of 1 unit. So in our lecture notes, we're going to say that we can see that 3 doesn't go in evenly, but 5 times 3 is 15, and then we have 1 left over. That extra tile, that is our remainder. And by the way, this is what I meant when I said capital R there. We indicate the extra leftovers with the R. So the extra value of 1 in example 3 is the remainder, denoted as R. 16 divided by 5, 5 goes into 16 3 times with a remainder of 1. So in this case, we would say that 5 is definitely not a factor of 16 because it doesn't go in evenly. In other words, 16 is not divisible by 5. So for my students, now is the time to pause the video and work on your turn 3. Again, this QR code on the right is for your color tiles if you want to use them. The other QR code will open up the poll so you can answer the questions here. Remember, this document is posted in D2L. Okay. So now let's talk about common factors. Remember, factors are numbers that multiply together to give you a particular product. They also are divisors. If 5 times 6 equals 30, that means that 30 divided by 5 is 6. It goes in evenly. 5 goes in evenly to 30, so that means that 5 and 6 are both divisors as well. So here we have on the left a rectangle representing 5 times 6, and on the right a rectangle representing 5 times 7. So 30 and 35, the areas of the rectangles, have a common factor, right? Again, these are called factors when they're a number that you multiply to get another number, and we have one in common, that's 5. So 30 and 35 have a common factor. It's possible for two numbers to have a bunch of common factors. Let's look at an example where we're going to practice listing out all of the factors of two different numbers and see which ones they have in common. I'm going to do this a particular way that is different than how they do it in my labs, and I tried to put instructor notes to remind you that you don't need to do it the way that they do it. What I prefer is that you just start with whatever the number is. And by the way, don't let it intimidate you if it's a large number. This goes faster than you would think. So what you're going to do is you're going to check all the numbers from 1 up to half of the number 24. So actually, I don't even want to say that. You'll see when to stop. I'll show you when to stop. So here's what you're going to do. You're going to say, okay, how many times does 1 go into 24? You are completely allowed to use your calculator here. So what am I really asking? 24 divided by 1 is 24, right? 1 times 24 is 24. Actually, I think I'm going to write a times symbol just to emphasize these are factors of 24. Then you can use your calculator again if you want to. 2 times what is 24? Well, 24 divided by 2 is 12. Then you go on to 3. 3 times what is 24? Well, you'll find that 24 divided by 3 is 8. Then you go on to 4. 4 times what is 24? Well, that would be 6. Then you go on to 5. 5 does not go evenly into 24. So you go on to 6. But you will notice that we already listed 6, and that's how you know that you can stop. As long as you've checked all the numbers up to this point, everything's going to just start repeating. So you can stop. We know that we have all of the factors of 24 listed. So the factors are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. All right, now let's list the factors of 16. Same way. 1 goes into 16 16 times. 2 goes into 16 8 times. 3 does not go into 16. 4 goes into 16 4 times. And look, we already have a repeat. When there's a repeat, we're going, I don't mean necessarily next to each other. See, this repeat was down here. We have to stop. So what are the pairs? 1 and 16, 2 and 8, 4 and 4 are the pairs of factors. Which factors do they have in common? So in this case, we're going to go through, we start with 1. They have 1 and 1 in common. They have 2 and 2 in common. They do not have 3 in common. They have 4 and 4 in common. Now let's go, keep going. Bigger than 4. I should probably cross off the ones I'm not going to use. We didn't use 3. 4 we already covered. You don't need to list it twice. 6 is not in common. 8, however, is in common. 12 is not in common, 16 is not in common, and 24 is not in common. You see how I went in numerical order? That was just so I make sure that I check everything and don't list anything twice. So I'm going to do 1, 2, 4, and 8 are the numbers they have in common. Now, which of these common factors is the greatest? Well, that would be 8. 8 would be the biggest value. So 8 is actually a special number. It's called the greatest common factor or greatest common divisor. Because remember, factors are divisors. Right? Why? Because 5 times 6 is 30 means 5 is a factor of 30. 30 divided by 5 is a whole number. 6 means it's a divisor. So whether you say factor or divisor, you really mean the same thing. So sometimes people say GCF for greatest common factor, and sometimes they say GCD for greatest common divisor. So in any case, it's just what the factor that they have in common that's largest out of the list. All right, so for my students, it's now time to do your turn 4 and enter your answers into the QR code. See if you get it right. Remember, if you have any trouble, you can always reach out to me. Okay, one last thing that I want to talk about is the different ways you can represent a remainder when you're dividing by a number that does not go in evenly. Depending on what situation we're dealing with, you can interpret a remainder in different ways and represent it in different ways. So in example 5, it says answer each question and explain how a remainder is involved in the solution. A says 11 cookies are to be shared by 3 children. Each child must get the same number of cookies. How many cookies does each child receive and how many are left over? Okay, so let's say this is the plate. We're going to draw some plates for our 3 children. We have 11 cookies. So I'm going to put a circle on each plate for each cookie and count them. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to stop because 10 and 11, I don't have, if the kids have to get the same number of cookies, I don't have enough to distribute to the 3 different plates. So this is a representation of 11 divided by 3 is equal to 3 with a remainder of 2 cookies left over. So in this case, the remainder refers to the leftover cookies. Okay, now it says 11 cookies are to be split exactly equally between the 3 children. How many cookies and partial cookies does each child receive? Okay, so we're going to take a similar approach at first. So I'm going to go ahead. I already know that I'm going to distribute 3 whole cookies to each of the kids. But let's think about these 2 leftover cookies. I'm going to split them equally, each one of them equally between the kids. So in other words, I'm going to have to divide them into 3 equal sized pieces. So if I do that, each kid is going to get a piece of this cookie and a piece of this cookie. So each kid is going to get a partial cookie. Okay, so we've distributed those, and now let's look on the plate here. How many cookies does each child have? Well, we know they have 3 whole cookies, but then they also have 2 of these little pieces, and each one of these pieces is a third. So 2 of these pieces would be 2/3. So each kid has 3 2/3 cookies. Now, it's not a coincidence that we had a remainder of 2 here, and down here we have 3 2/3. What did we end up doing? We had to divide those 2 cookies into 3 pieces in order to fit them on the 3 plates. So, a remainder can be represented both as just a whole number left over or as a fractional leftover. 3 2/3 is the same result as saying 3 with a remainder of 2, since we were dividing by 3. So when a number does not divide evenly into another number, sometimes we set the remainder aside, while other times we divide the remainder by the number that results in a fraction or decimal. So I want to show you another example of that. So 16 divided by 5, we already said 5 goes into 16 3 times with a remainder of 1. If we were talking about splitting a cookie amongst 5 individuals, each of those individuals would get 1 divided by 5. The remainder would have to be divided to 5 equal pieces. So another way to represent this is 16 divided by 5 is 3 1/5. Now, what would your calculator represent 16 divided by 5 as if we do a decimal? 16 divided by 5 would be 3.2. So in this case, we're representing that leftover piece as 0.2, which means 2/10, by the way, which is the same as a fifth. So what has happened here is that one piece was divided by 5 into 5 to distribute it equally again. So depending on the scenario, you can have the remainder left as a whole that we're leaving out, or you can have it divided up into pieces and represented as a fraction or a decimal. So now I would like my students to work your turn number 5. So pause the video and try your turn number 5. Okay, the last thing I want to talk about in this video is finding a remainder using your calculator. If we're going to leave it as a whole leftover part, because your calculator again is going to give it to you as a decimal, and there's going to be some applications where remainders are going to be important to us. So before we get into all of that in the upcoming lessons, I want you to be able to use your calculator instead of having to do that whole long division thing you may have learned in the past. So for example, I'm going to use my calculator here to divide 21 divided by 2. That gives you 10.5. So on a calculator, 21 divided by 2 is 10.5. But remember, the decimal part of this is has already been divided by 2. So if we want to work backwards and figure out what whole number remainder we started with, we would multiply the 0.5 by the 2. So on your calculator, what you're going to do next is you're going to subtract off the whole number part. You could, in this case, just type in 0.5, clear out and just type in 0.5, and when the numbers are bigger, this will be more convenient. So I like to say subtract off the whole number part and then multiply by whatever you were dividing by, which in this case is 2. So you're going to say times 2, and this should give you your remainder. So we're going to say take away 10 equals, we're going to multiply that, just the decimal part, by 2, because remember it had already been divided by 2 to get it in decimal form. And that's going to leave us with a remainder of 1. So instead of writing 21 divided by 2 equals 10.5, we're going to say 21 divided by 2 is 10 with a remainder of 1. This is the answer I'm looking for. Okay, let's try that again. The next one is 44 divided by 8. By the way, this means the same thing as 44 divided by 8. Okay, so I'm going to go on my calculator here. I'm going to clear out my old problem. 44 divided by 8 equals, that's going to give me 5.5. I'm going to subtract off the whole number part, not the decimal part, just the 5 that's in front of the decimal. This is going to leave 0.5. By the way, it's not always 0.5 at the end. But this is interesting that it turned out the same, because watch what happens next. We're not going to multiply by 2. We have to multiply by whatever number we were dividing by, which in this case is 8. So we're going to multiply by 8. And that gives us our remainder, which 0.5 times 8, you can see, is 4. So we're, instead of saying 44 divided by 8 is 5.5, we're going to say 44 divided by 8 is 5. This is the whole number part that we had before, with a remainder of 4. And that makes sense, right? Because what's 8 times 5? 8 times 5 is 40, plus 4 would give you 44. Okay, let's try one more. This has got some bigger numbers now. So, and I promise you it's not going to end up to be 0.5 this time. So fraction is division as well. So this really means 213 divided by 47. Clear out the old work. 213 divided by 47 is, so now this has this big long decimal, and so it's, I'm not even going to write it on my paper. I'm going to now subtract. I'm going to write 4.53 dot dot dot, just so you know what I did. Okay, but I'm going to subtract off the whole number part. What's the whole number part in this part? The 4. We just want the decimal, so subtract 4. That just leaves us with the decimal. Okay, so the decimal is 0.53, etc., etc. But I don't want to round off. I want to multiply that by 47 because that's the number we had divided by to see what the remainder would have been. Times 47 is 25. So the remainder is actually 25. So instead of saying 213 divided by 47 is 4.53 something, we're going to say 213 divided by 47 equals 4 and 25. Oops, sorry. I almost wrote it as a fraction. 4 with a remainder of 25. It goes in 4 times with 25 left over. All right, so for my students, you're going to do your turn 6. It's going to be very similar. And then please remember to go do your MyLabs homework. I hope you found this video helpful. If you did, please give it a thumbs up. That helps other students to find the video. You can also subscribe to my channel, Mr. Mathematics, for more math videos.